This is nearly a true story. The events happened about 11 years ago at Timeshare, a company which provided commercial time-sharing services. This story is an excerpt from a famous 1988 computer science paper, and at the end of the story we will understand why the browser is a very confused deputy. But let's continue with the story. Our operating system was much like Unix in its protection structures. A compiler was installed in a directory called SYSX. A user would use the compiler by saying run SYSX/fort and could provide the name of a file to receive some optional debugging output. We had instrumented the compiler to collect statistics about language feature usage. The statistics file was called SYSX/stat, a name which was assembled into the compiler. To enable the compiler to write the SysX stat file, we added the compiler SysX4 to the user group. The operating system allowed a program with those permissions to write files in its home directory, SysX in our case. The billing information file sysxbill was also stored in SysX. Some users came to know the name sysxbill and supplied it to the compiler as the name of the file to receive the debugging information. The compiler passed the name to the operating system in a request to open that file for output. The operating system, observing that the compiler had user permissions, let the compiler write debugging information over sysxbill. The billing information was lost. Who is to blame? What can we change to rectify the problem? Will that cause other problems? How can we foresee such problems? The fundamental problem is that the compiler runs with the authority stemming from two sources. That's why the compiler is a confused deputy. The invoker yields his authority to the compiler when he says run sysxfort. The other authority of the compiler stems from its user group permission. The compiler serves two masters and carries some authority from each to perform its respective duties. It has no way of keeping them apart. When it produces statistics, it intends to use the authority granted by the user group permission, and when it produces its debugging output, it intends to use the authority from its invoker. The compiler had no way of expressing these intents. The Confused Deputy, Norman Hardy, 1988. Wikipedia summarizes this as, a confused deputy is a computer program that is innocently fooled by some other party into misusing its authority. It is a specific type of privilege escalation. Authority might sound weird at first, but authority simply means that it was given the permissions and ability to perform a certain action, and it might have unintended side effects because there are multiple authorities involved. And this is what we see on the internet. The confused deputy here is the browser. The browser was given authority to handle the sensitive user-authenticated sessions of a website, but sometimes a third party is invoking the browser to perform something unintended. For example, cross-site scripting. A browser simply executes JavaScript. A browser doesn't know if a script is malicious or good. Like the compiler in the story didn't know if the file name passed to it is good or evil. But because the browser has the authority of performing authenticated requests, somebody controlling this JavaScript can fool the browser to do something bad. It's not the attacker who performs the request. The browser is executing the attack, not intentionally. But that's why we call the browser confused. Same thing with cross-site request forgery. A browser will simply parse HTML and fetch every image embedded on its site. It doesn't know if a certain image source is actually a URL that has bad side effects, like deleting a user account. But again, the attacker tricked the browser into executing a privileged action. And the weird thing is, neither executing JavaScript nor handling authenticated sessions is a security vulnerability. This is not a bug in the browser. This is how the browser is supposed to behave. Hell, even injecting JavaScript into a site by itself is not a vulnerability of the web application. You don't get code execution on the server with that. You don't get access to private user data directly from the server. Only because the browser has special authority and we trick the browser into doing it for us, it suddenly evolves into a security issue. And I believe that this is a good way of thinking when approaching and researching a new piece of software. don't always look for this single shot vulnerability, this one buffer overflow to rule it all. Think about what kind of legitimate authority your software has. What are the permissions and privileges it has that you don't have? And once you identified such a system, ask yourself, can you outsmart it? Can you use the system to do something else? Like we indirectly use the browser to do actions? As Wikipedia says, this is a special kind of privilege escalation. You don't have the privilege to access the private Facebook messages of another user, but if you get JavaScript into a Facebook page, then suddenly you can confuse the browser and indirectly derive this privilege. Now, another confused deputy on the internet is the web server or the application running on it. There's a cool vulnerability kind that is related to cross-site request forgery. Just instead of making the browser perform a request, we make the server executing a request. This is then called server-side request forgery, SSRF. There's a legitimate use case why a server would want to be able to perform requests when a user asks for it, but this can have devastating results. But SSRF will be a topic for another video. Something I haven't mentioned yet is that the confused deputy story is actually about introducing a reason for a different permission model called capabilities, but we won't go into that now. I just think the concept of a confused deputy is important to know and provides a good abstract classification of security issues. What do you think? Is that an important way of thinking? See you next time, and I hope you don't get confused.